All right, this video, I start every video by saying all right. I need to find some other openers. Okay, that'll work. All right, so this, damn it. Had to sneeze, I'm still sick. This video is scientific notation. I'm gonna try to make this as brief as possible, but it seems that I'm very long-winded and my videos will be about 10 minutes long. I will try to make this one shorter. This video is going to be about how to go from between scientific notation and standard notation. So hopefully you have the steps in my PowerPoint on its learning, because I'm not posting them here. And I'm sorry. Not sorry. All right, so first of all, why do we even care about scientific notation? The reason being is because if you consider this right here, here's a little picture I drew. This picture is showing you the sun. That's the sun here. That's the sun. It's hot. And then we have these three planets here. Here's Mercury. I have the wrong color. Here's Mercury. And then there's Venus. And then this is us, Earth. And then stuff behind us. So who cares? But I do believe that the distance between us and the sun, I want to say, was it 92.96 or 96.92 million miles, something like that. But hey, you know, it's beyond like one, so who cares, right? No. But anyway, just for the sake of argument, or the sake for this, let's just say it's 92 million miles, okay? So that's how far it is from Earth to the sun, approximately 92 million miles. If I were to do some math in here with that number, 92 million miles. I am lazy. Do I feel like writing all those zeros and stuff over and over, especially if I gotta like multiply that number by like 100 million or billion? That's a lot of zeros you're gonna have to write over and over. Okay, ain't nobody got time for that. All right, so scientific notation helps us write these very large numbers in a very easy and convenient way without having to write out all of the zeros. So let's look at how to write a number as scientific notation. And I guess since I'm showing it here, here was the other example, or the other reason why we want to use scientific notation. In chemistry, you're going to learn about what's called the mole. And the mole is a way for us to easily group together large numbers of molecules and atoms and things, because atoms and molecules are very small. So if we want to talk about an amount of them that we can visibly see with our eyes, we're going to be using moles, because one mole of anything is going to have Avogadro's number of things. But if you haven't gotten into chemistry and you don't know anything about that, then you can ignore what I said. But just understand this, that if we're talking about having what's called a mole of water, then 1 mole of water is going to have, oh gosh, 11, 12, 15, 16, 17, 18, 19, 20. Is that 20 zeros? I think it is. I don't feel like going back and counting. But that should be a very large number. 6022 or 6.06023, depending on how you feel like writing it, with a bunch of zeros behind it. That's how many molecules or atoms, molecules of water you're going to need, or atoms of anything, if you have 1 mole of it. So for water, you're going to need that many approximately molecules of water just to have what we call 1 mole of water. So that is a lot of molecules of water. If I were to have more than 1 mole of water, I'm not going to feel like writing all those zeros over and over. I mean, hell, if I want to write down what the size of an atom is, it's ridiculously small, okay? That's going to be, if I want to have like the size of an atom in, I don't know, feet or something, you're going to have a number with a lot of decimal places, okay? Nobody has time for this, okay? I don't feel like doing that, all right? So that's what scientific notation is for. I've spent 4 minutes showing you why scientific notation is important, so hopefully you get the point. So how do I write a number that's large or small in scientific notation? Well, what does scientific notation even look like, okay? If I'm talking about that distance between the Earth and the sun, which I am going to say was about 92 million, then it'll look like this. 92 million, which is this, will be written in scientific notation as 9.2 times 10 to the 1, 2, 3, 4, 5, 6, 7th power. This is 92 million written in scientific notation. If I were to write the other number I showed you, which we call Avogadro's number, that number was, let me use a different color so you don't get confused here. 6022, gosh, I can't believe I'm about to do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I'm not doing this, okay? But if I were to write that in scientific notation, 6.022 times 10 to the 23rd power. Okay, that's Avogadro's number, written without having to write all those ridiculously large number of zeros. So how do I do it? I've been doing this a lot. I've done it more than enough times. Okay, I've probably done this Avogadro's number of times. Okay, that's overestimation. But when you do this a lot, that practice, it becomes second nature. So just as easily as how I've written those numbers in scientific notation, if you practice it enough, you'll be able to do the same thing. So let me just show you how to do that. Okay, so let's look at the example for the distance between here and the sun. So looking at the actual, the original number here, what you're going to do is you're going to find what the decimal place is. So the decimal place right now is behind the 1 spot. There it is. We're going to move it so that there's only one significant number in front of that decimal. Hopefully you know what significant figures are. The first significant number or figure in this entire number is the 9. This is the first significant number in the number. It's the first number in the number. So that's the only number we want in front of the decimal. So we're going to move the decimal over as many times as we need until we have just the 9 in front. All right. So how many times did I just move that decimal? 1, 2, 3, 4, 5, 6, 7 times. So we got 9.2. I'm going to rewrite all the junk. If you know about sig figs, you know that these zeros are not significant. If you don't know about sig figs, watch a video on sig figs. But we're going to erase those insignificant zeros, so we're just going to keep the 2. So we got 9.2. We moved that decimal 7 times to the left. So you got your decimal in the new spot. So what you're going to do right behind it is just write your times 10. We know that multiplying or dividing by 10 in math class, that's how you move decimals around, okay? So you put times 10. How many times did we move? We moved 7 times, so it's going to be 10 to the 7th power. Now, which way did I move? I moved the decimal to the left. So the exponent will be positive because it's a big number. It's 92 freaking million. So that means, of course, the exponent needs to be positive, all right? So that means the answer here, in scientific notation at least, it's 9.2 times 10 to the 7th power. If you're using a graphing calculator or some type of scientific calculator, the calculator would like for you to write it like this: 9.2 e positive 7. Or some calculators don't even like to use the positive sign. They'll just say 9.2 e 7. Okay, but these all mean the same thing. Okay, that is scientific notation. I actually like the E. I prefer the E because I just wrote 4 things. Well, 5 if you count the decimal. I wrote 5 really quick, easy things. Okay, and it's really easy to put that in the calculator. What about a really, really, really small number? What about a really small number? Let's say I have a small number, like how much money I have in my bank account. All right. 0.000000901. Let's say that's how much money I have. I don't feel like writing those zeros. Let's put it in scientific notation. We do the same thing. We want to have one significant number in front of the decimal. Zeros are usually not significant. If you know about sig figs, as a matter of fact, none of these zeros are significant. So the only number that needs to be in front, what's the first significant number here? 9. So that's the only number I want in front of the decimal. So to get that decimal right behind that 9, let's move it 1, 2, 3, 4, 5, 6 times. So that decimal is right behind the 9. We're going to put the important stuff behind it, 0 and 1. I really hope you know about sig figs, because some of you are probably saying, well, she just got rid of the zeros in the other video or earlier. Why is she keeping that 0? That zero's in the middle. Why would you get rid of it? Okay, it's important. Duh. It's a sandwich 0. All right, so we got 9.01. You're going to write times 10 right behind it as usual, but now we got to put a new decimal. How many times did I move? 1, 2, 3, 4, 5, 6. I like to do the humps because you can just count the humps. 1, 2, 3, 4, 5, 6 humps. So it's going to be 10 to the 6. Since this was a really small number, I moved to the right. The exponent needs to be negative now. Small numbers, negative. So in scientific notation, this is 9.01 times 10 to the minus 6. And there you go. What if you have a number in scientific notation and you want to take it out of scientific notation and put it into standard notation, which is numbers as we usually regularly write them? It is the opposite. It can be tricky when you're thinking about the directions to move, but if you practice this enough, you will get it. Let's say that I have this number. Let's use a different color just to be pretty. Let's say you have a number like 2.41 times 10 to the negative third power. And then let's try another number. 2.41 times 10 to the positive third power. All right. So looking at the top number, 2.41 times 10 to the minus 3. So you have your number 2.41. You have your negative 3 as your exponent. So you're basically going to do what I showed you, but in reverse. So we look at the exponent. Is it positive or is it negative? We see here it is negative right here. That means we're going to move the decimal to the left. If you look at the number 2.41, moving the decimal to the left will make 2.41 become a small number. So that makes sense because the exponent is negative. Negative is small. All right. So we're going to move to the left, but how many times? You guessed it, 3 times. What did I just write? 3 times. So let's do it. 1, 2, and 3 humps. Here's the new spot for the decimal, and fill in zeros to your empty spaces. Please get rid of the old one. I hate when people leave those decimals there. Erase it or something. So what is the answer in regular notation or standard notation? 0. And write your numbers. 0, 0, 2, 4, 1. There you go. What about this one on the bottom? 2.41. We're moving 3 times, but since it is positive, we're going to move to the right, which makes sense. 2.41, if I move the decimal to the right, that'll make the number bigger. It's a positive exponent, so that means big number. So 2.41, move the decimal to the right 3 times. Bam, bam, 3, bam. Empty spot, put a 0. Here's the new decimal place. X the old one. That's 2,410. And that's it. Peace.